transition metal transitions in a complexes in which, see, one of the very important diagram that is, you can say it's a Orgel diagram. How the different term is splitted, so that is we have already seen in the previous lecture. Okay, splitting of different term into different orbitals, so that is we have already checked it in a different field. See, this is the different configurations where different term is there. So you can say it is splitted into various terms. Now these are this ground term, particularly in the case of this is the ground term. In a D1 and D6 system is concerned, so ground term is E term. E term is the ground term for D1 and D6 system. Now if you're coming to D2 and D7, then ground term is T term. And for D3 and D8 for octahedral, ground term is the A to G. A is the ground term. So A2 is the ground term. So in short, here see, these are the diagrams for different systems or splitting of different term. Especially F term is splitting into 7 different orbital terms, that is called A1G, sorry, A2G, T1G and T2G. Similar way, you can have a T term. T term is P term. P term is split into T1G and S term is split into A1G. So these are the various Mulliken term. And according to this Mulliken terms, splitting is this. So this is the general diagram for D2, D3, you can say D7 and D8, D3, D8, D2 and D7 system in Buddhi field. Okay, so electronic configuration in tetrahedral and octahedral field, how the splitting is take place. So Orgel diagram for high spin octahedral complex. Orgel is only applied for weak field complex, remember. So now we are going to discussing today, that is Orgel diagram for octahedral complexes with a different system. Now splitting of different term we have already seen. So what happens in the Orgel diagram of you can say so see, Orgel diagram is only applied to
ground state.
yes, is only applied to, you can say, weak field complex. Weak field complex. That is, it is applied to ice. See, weak field is there, so it is high spin complex. It is applied to high spin complex. So in the case of D1 electronic configuration of octahedral, high spin octahedral complex, if you having D1 configuration, D1 octahedral weak field complex, what happens? So it's a system is a D1. So you can have a 1 electron in a d orbital.
2t.
Okay, so
2
term
capital
is,
T.
yes, multiplicity is 2s plus 1 is doublet. L value is 2, so it's a d term. So term become doublet d. So if you draw the plot of energy versus octahedral splitting, then what happens? This is the term which is called doublet d term. This is a doublet d term over here. It is splitting into two terms. One is called doublet Eg and another one is doublet T2G. So doublet T2G is a ground term. Okay. Doublet T2G is the ground term. So how many different transitions are there? You can have a only one transitions. So allowed transition electronic transition are only one, that is from double ground term T2G to doublet Eg. This is, you can say, new one. So various example of this type of the systems, that is called D1 systems, are TiCl6 -3, TiH2O 6 plus
6
3.
3 plus.
Yes, in short, it's a titanium plus 3. So it says 22 atomic number. So titanium plus 3 is an example of D1 system. You can have a Ti NH3 6 time plus 3. So for, see, in the case of D1, D2 and D7 system, you can have a see 10 dq equal to nu2 minus nu1 also. D2 and D7, I am talking about this D2 and D7 system. 10 dq equal to nu2 minus nu1. Is it okay? Nu2 minus nu1. That is called 10 dq value. That we see later. So this is formula you can remember. So in the case of TiH2O6 plus 3, it shows one absorption band that is broad, composite and unsymmetrical because of the John-Taylor distortion. If you compare all these three complex, so what happens? In the case of TiH2O6, so only one absorption band, that is broad, composite, unsymmetrical, because of John-Taylor distortion. Or you can say band observed is unsymmetrical, broad or composite. Okay, in this complex. So you can have a, see, it is a due to this composition, but other complexes shows two band because of the John-Taylor distortions. Remaining two complex. So instead of getting one, Other complexes shows two band. This band is around at for the case of H2O, it is around at 20,400 centimeter inverse. But remaining two, that is TiCl6 minus 3 and another one is TiNH36 plus 3. Shows two absorption band. Due to John-Taylor distortion. Of course, this band is unsymmetrical, broad and composite. Bands are unsymmetrical, broad and composite. So this is about D1 system. It is very famous for John-Taylor distortion. But the case where you are getting two absorption band for NH3 and Cl6 type complex and one absorption band with H2O complex, and that is two absorption band is due to John-Taylor distortion. Now in the case of D6, what happens? Now we're coming to D6 system. So D6 system is concerned. Which term is there again in D6? D6 octahedral complex, weak field complex. Which term is there? Which term is there in D6 complex?
Sir, D.
What is multiplicity? Of course, L value is 2, so it's a D term, capital D. But what is 2s plus 1 value?
9.
No, it's not 9.
5.
5, yes. It's a 5. Of course, there are 4 unpaired electrons, so it's a 2. S value is a 2, so 2s plus 1 value is 5. So it's a quintet D term. So if you again go for its diagram, what happens? You can have a octahedral splitting versus energy. So this term become quintet D. So in such a case, so this term is again split into two term. Quintet G. So see diagram for D1 system and D6 system is similar, but there is only change in the multiplicity. Multiplicity gets changed. Rest of the things are similar. So in this case, see Fe H2O6. This is a complex which is having D1 system. It gives two two absorption band.
Sir, D1 or D6?
D6. This is a D6 Fe. Okay, because it's a 20 atomic number is 26 for Fe. It's a plus 2 state, so it's a D6. It shows two absorption band due to John-Taylor distortion because of John-Taylor distortion. So it's a D6 system. D6CO plus 3 and Fe plus 2. So Fe plus 2 and CO plus 3 is especially example of CO plus 3 are CO, ethylene diamine, tris ethylene diamine plus 3 complex, COOX twice minus 3. So see here, this complex is there where you can have a two different possible arrangement in high spin complex and low spin. So see for low spin, Tanabe-Sugeno diagram is there. So we go for later on that diagram where you will get two transitions. For this Buddhi complex, you can have a TS diagram where singlet A1 G2, singlet T1 G and singlet A1 G2, singlet T2 G is also observed. This type transition, but that is the case for TS. For high spin complex is there. It's a Orgel diagram. So depending on the types of complex, you can have a such a diagram, but that is the case for a particular D6 system. Now what happens in the D4 system? चलो
Sir,
D4 and D.
TS या L है?
क्या?
Sir, TS diagram sir क्या है?
वो तो Tanabe-Sugeno diagram है. It is applicable for both high spin and low spin. तो वो जो है वो थोड़ा complicated है. उसमें number of transitions are. It is applied for both weak field and strong field. तो दोनों मिला के काफी सारे ट्रांजिशंस हो गए तो एक दूसरे को ओवरलैप भी करेगी तो वो इसके बाद देखेंगे वन बाय वन डिफरेंट सिस्टम के लिए व्हाट इज टीएस डायग्राम. ओके, दिस इज ओरगल डायग्राम. इट इज क्वाइट सिंपल.
और सर ये 1 बैंड 2 बैंड ये सारा एक्सपेरिमेंटल डाटा है ना?
ये एक्सपेरिमेंटल है एक्चुअली. से एक्सपेक्टेड यहाँ पे 1 है देखो T2 G2 EG. ओके, दिस इज एक्सपेक्टेड इज ए 1. सो इन नॉर्मल केस इट्स ए 1 बैंड बट एक्सपेरिमेंटली Q2 बैंड मिल रहा है. सो दैट इज सम सॉर्ट ऑफ जॉन टेलर डिस्टॉर्शन in particular complex. Okay.
Okay sir.
In the case of D4 system, D4 octahedral Wickfield complex. So you can have a which term is there in D4 and D9? case of D4, +2 +1 0 -1 again D term. Multiply it is 5, so it's
5D.
yes. But the difference between these two is ground term gets changed, so it's you can say here is a transition from quintet EG to quintet T2G. D9 के लिए भी ऐसा ही आएगा सी D9 सिस्टम है तो डबल डी टर्म आएगी, बाकी सब सेम रहेगा. इट्स a doublet term, doublet D term. Splitting is again same. इनका एग्जांपल है D2 सिस्टम के लिए आप कॉपर लिख सकते हो, कॉपर H2O6 +2. Here it's CrH2O6 +2. Chromium +2 is the example of D4 system. Now see, this complex expected one is in case of copper complex, expected transition is a 1. But see, is there you are getting 1 or you are getting more than 1? Here you are getting
सर 1 होना चाहिए.
नहीं 1 तो है, बट यहाँ जोनेटल डिस्ट्रीब्यूशन होगा या नहीं होगा?
होगा सर.
Yes, sir.
D9.
Yes, so D9
Strong.
होगा जोनेटल, strong जोनेटल
Strong.
है. So here see, because of the distortion, what happens? It gives above complexity. This gives 3 absorption band. In their spectra because of JTD. Because of John Taylor distortion, you are getting 3 band. Now, if you see having this one of the complex, like you can have a copper sulfate. What is color of copper sulfate?
Blue.
Yes, CuSO4 has a blue color. Between, so see, between it's it is when it is heated, it become colorless. Why? Normally, see, this is already asked in that exam, like CuSO4 into 5H2O has blue color. It has blue color. After heating, it become after heating it becomes colorless. Why? It's already in blue color, so when you heat it, it become what happens? What is its answer?
5:2 eliminated.
Oh yes, only see 4H2O. 1H2O still remains with it, but 4H2O water content gets eliminated and it become colorless. So hydrated form is a color and this is a colorless. So 1H2O is still remains with this one. So in this case, see, octahedral and tetrahedral geometry. Here, see, in this case, there is no octahedral and tetrahedral geometry in this complex. Okay. After heating, you can have only one H2O. Normally, you see what happens. It has, if you go for copper sulfate into 5H2O, so you can have a octahedral type geometry. But after heating, that octahedral geometry gets lost. So, see, normal case, if you're having its structure is like this. Yes, this is its structure. There is no tetrahedral even. See, CuSO4, OH2, OH2 here. See, this is a, you can have see this type of the structures where here SO4 group is there. This type of hydrogen bonded structure is there. You can have here this is the case in a case of, you can say, this type of hydrogen bonding is there. You can have a here another, again SO4. These are the 4 water molecule. Again, it is attached to SO4. So one water molecule is over here, H, O, H. Another water molecule is over here, H, O, H. So this type of hydrogen bonding is there and copper is there in a octahedral state. This is just a square planar geometry. So what happens? See, after heating, water molecule gets lost. So copper sulfate, once you can heat it, so water, it lost the water molecule, and therefore it also lost the octahedral and tetrahedral geometry. So there is no splitting of the orbital. because splitting of d orbital is take place in octahedral and tetrahedral geometry. So there is no dd transitions and therefore it is colorless. Originally CuSO4 into 5H2O is a octahedral and d orbital gets splitted and you can have a dd transitions in copper sulfate into 5H2O. So this is a color because of the dd transitions. CuSO4 into 5H2O is a octahedral. Okay, it's a octahedral. So it splitted, it gives dd transition. And therefore it is color. But what happens in the case of CuSO4 into H2O is not either octahedral nor it is not either octahedral or tetrahedral. So what happens? It does not give dd transitions. So it does not gives dd transition. And therefore it is colorless. Is it clear up to here?
Yes, sir.
D1, okay, D1, D2, D1, D9 and D4 and D9 and D1 and D6 system are quite simple and having only one term. Now one of the very important system and diagram is also very important. So that is for D2 system. Now we move to the D2 electronic configuration. So in the case of D2 system, you can have a two electron gets accommodate in particular, you can say first arrangement is it is this one. So what is the multiplicity with term?
F.
Yes, it is a F term. It is, you can say F term, that is L is equal to 2 plus 1, that is 3. So it is a F term.
What F?
It is of course 2 electrons are there, so it's a quadrate F. Good. Another arrangement is possible arrangement with the same multiplicity is you can have a C2 electron in plus 1 and 0. See, of course this is possible. What is its multiplicity?
1
L
P.
value is 2, so it's a
P.
triplet P. Okay, it's a triplet P. So there are two terms which is involved in this diagram.
पर में 3F क्यों नहीं होगा?
कैसे आएगा ये सब बताओ, किस में इलेक्ट्रॉन लगे तो ऐसा आएगा?
2s plus 1 होगा, half 1 होगा, 2 into 1 plus 1, so 3.
ओके, वो ये पूछ रहे हो ट्रिपलेट कैसे आएगा? ट्रिपलेट तो बता दिया हमने, सिर्फ ट्रिपलेट एस क्यों नहीं है वो पूछा। एस टर्म तो कैसे आएगी, किस में इलेक्ट्रॉन लगे तो ऐसा आएगा? दो इलेक्ट्रॉन आप +1 और -1 में लगे तो आएंगे, तो ऐसे पॉसिबल नहीं होता है। इट्स हैविंग मैक्सिमम मल्टीप्लिसिटी टर्म वी आर कंसीडरिंग। सो ट्रिपलेट P है, दूसरी जो टर्म है वो ट्रिपलेट F है, सॉरी ट्रिपलेट F ही है, ट्रिपलेट F। तो दोनों की मल्टीप्लिसिटी सेम है। नाउ यू कैन हैव ए, तो बाकी के डायग्राम में से ये दो टर्म आएगी, इसके अलावा और भी पॉसिबल टर्म्स है और डिफरेंट अरेंजमेंट करके आप लिख सकते हो कि भाई टू ऑर्बिटल जो है ना +2, उसमें दोनों इलेक्ट्रॉन अनपेड कर पेयरिंग कर दो तो भी ये सिंगलेट टर्म आ सकती है, बट दिस ट्रांजिशंस आर स्पिन फॉरबिडन, they are not allowed because transition with same multiplicity is only allowed and therefore we have not considered it. Okay, तो जो सिमिलर बट टीएस डायग्राम में वो सारे ट्रांजिशंस है कि अलाउड और फॉरबिडन, बट इसमें इसी ओनली अलाउड ट्रांजिशंस आर देयर। सो दो ही टर्म हमने सिलेक्ट की है, दैट इज ट्रिपलेट, one is triplet F and another one is triplet P. Now you tell me which one having lowest energy among these two?
3F.
Triplet F, yes. And then it's a triplet P. Okay, so how they get splitted? So see, triplet F is splitting into,
3. A1 to
it is
A2G,
splitting
3
into triplet T1G
T2G, and A2.
and triplet A2G. See, this is a triplet A2G. Now P term is splitted into T1G, triplet A2G। यहाँ पे आप F लिख दो ब्रैकेट में क्योंकि ये F की टर्म है। यहाँ सी ट्रिपलेट P term is splitted into triplet T1G. So how many transitions are there? Expected transitions
4.
कौन कौन से बताओ? ग्राउंड स्टार्टिंग फ्रॉम ग्राउंड ट्रिपलेट T1G,
So 3.
सिर्फ मैं बताता हूँ आपको एक्सपेक्टेड। दिस इज बॉन्ड दैट इज फ्रॉम ट्रिपलेट, सॉरी इनके लिए थोड़ी
T1
एफ टर्म से एफ टर्म का स्प्लिटिंग गलत लिखा है। एफ टर्म में एक और टर्म आएगी, कौन सी है?
T2.
T2.
यस, इट्स अ ट्रिपलेट T2G, गुड। सो यहाँ पे एक और टर्म आएगी दैट इज कॉल्ड ट्रिपलेट T2G। Now you tell me the expected transitions are 3. Which are these 3 transitions? So see, this is the first one from triplet T1G to triplet T2G. Then this is the second one. So second one is from triplet T1G to triplet A2G, and you can have a third one is this overlapping. So you can have a second, and this is the third one. So there are 3 transitions which are possible. So now you tell me, in these 3 transitions, what happens here if you go for, or you, what's about its intensity? Here, what is its intensity in this case? In the case of D2 system, you can have a see these are the 3 different transitions. So first you write down the yellow transition. First one is you can have a ground term is triplet T1G F2 triplet T2G, then triplet, after triplet T2G, the next one is Which one is the next?
T1.
Triplet T1G. Okay, then
A triplet A2.
triplet A2G.
A2.
So these are the three different transitions which are possible with D2 system. Now you can go for energy. You can compare its energy. So energy wise, which transitions having which type of the energy, if you want to predict its energy, so what happens? You can say this is a new 1, this is new 2, and this is new 3. If you're coming to especially
Me1 greater than Me2 greater than Me3.
coming to this one, say this is the F term splitting. But this is the F term. In the F term, what is this value? And what is this value? Here this is new 1 and this is new 2. New 1 is how many DQ?
8.
Sorry, this is a D3 system. Okay, what is D3 system? What is new 1?
18.
-4.
It's minus 6 DQ. Two DQ. Okay, it's a minus 4. Here you can come into D2 and D7. Well, let's. Okay, now see here you can see me the different transitions with energy. What is energy order? E3 is greater than E2. E2 is greater than E1, or you can say new 3, new 2, and new 1. So what's about wavelength lambda?
Reverse.
Inverse. So see, this is the wavelength order. Now see, in the case of H2O complex, what happens? In the case of VH2O6, vanadium H2O6, see expected one are, actually see what happens here, this transitions gets overlapped. So see, in the case of H2, you are getting has only 2 band. But V NH3 6 time plus 3 has 3 absorption band. तो वाटर कॉम्प्लेक्स में एक एब्जॉर्प्शन बैंड है वो कम मिल रहा है, दैट इज बिकॉज ऑफ द ओवरलैपिंग. तो कौन सा ओवरलैपिंग होगा?
T1G and T1 Ta2G.
Yes, it is overlapping which is take place between T1, जो T1G वाला है ना, P वाला, वो ओवरलैप हो जाएगा, वो पीछे के साथ उसके साथ ओवरलैप हो जाएगा. सो इट विल बी नॉट शोज द ट्रांजिशंस. D2 के केस में ये ट्रांजिशंस है वो नहीं मिलेगा आपको, क्योंकि बिकॉज ऑफ द ओवरलैपिंग.
सर
बट
किसके
यहाँ
साथ ओवरलैप करेगा?
ओवरलैपिंग दैट मीन्स ये जो f ऑर्बिटल्स के बैंड है उसके पीछे ये आ जाएगा, p ऑर्बिटल्स का बैंड ओवरलैपिंग होता है. सो दैट विल नॉट गिव यू दी और दिस ट्रांजिशंस फ्रॉम T1G to T1GP. ये ट्रांजिशंस ये वाला जो है निकल जाएगा इन द केस ऑफ H2O. बट उस केस में ओवरलैपिंग नहीं होगा. देयर इज नो ओवरलैपिंग इन दिस केस. वेनेडियम NH3 टाइप कॉम्प्लेक्स ये ऐसे आएगा. सी, तो ये डायग्राम आपको पर्टिकुलर ये कॉम्प्लेक्स देख के चेंज होगा, यहाँ पे ऐसे आएगा. सी, so here you can have a triplet F and triplet P. what happens here? T1GF, उसके बाद नेक्स्ट आएगा ट्रिपलेट T2G, देन ट्रिपलेट A2G, और p ऑर्बिटल कैसे सेपरेट रहेगा? ट्रिपलेट T1G। तो उस केस में आपको कितने ट्रांजिशंस मिलेंगे? यहाँ पे जो ऊपर लिखे वो सारे मिलेंगे। इसे न्यू1 कौन सा रहेगा यहाँ पे? यहाँ बेटर है न्यू1 न्यू2 चेंज कर दो, इनको न्यू1 बोल दो। एक्सपेक्टेड हम लिख रहे हैं तो पहले एफ वाले लिखो सारे। This is called nu2 and this is called nu3. ये पीछे की साइड है, ये हिडन है अभी, बट यहाँ आपको पूरे ये 3 ट्रांजिशंस मिलेंगे। न्यू1 टू न्यू1 जो है वो ट्रिपलेट T1GF, ऊपर जो लिखे ना ये सारे 3 ट्रांजिशन इसमें मिलेंगे। तो इस केस में इंटेंसिटी ऑर्डर कैसे आएगा? चलो, these are the possible transitions. This is first one, second, and this is third. First is called nu1, second nu2, third nu3. तो ये ऑर्डर आएगा ऐसे। तो वाटर मॉलिक्यूल है, उस केस में देखना है ऐसे वहां पे ओवरलैपिंग हो रहा है, and because of the overlapping you can have a one less transition than that of the expected one. But again, see, same overlapping does not take place in the case of D7 system. A overlapping here, it is take place in case of D2 system only. If you have see D7 system is there, so multiplicity is 3 अनपेड इलेक्ट्रॉन है, कितनी मल्टीप्लिसिटी आएगी?
40.
4. It is quadrant term. So
4f.
see, in this case, whether it is water complex or any complex, there is no overlapping. तो इसमें कैसे ट्रांजिशंस मिलेंगे? आपके पास ये 2 टर्म है, p टर्म एंड क्वाड्रेट f. So quadrant f term is split into, फर्स्ट कौन सा आएगा? क्वाड्रेट T1G, ओके। सेकेंड
T2.
क्वाड्रेट T2G, देन
A.
quadrant
A2G.
A2G and quadrant T1G
T1G.
P.
P.
So there are again 4 transitions, but here see whether it is water complex or any complex, in higher system there is no overlapping. This is nu1, this is nu2, and this is nu3. So allowed transitions are first one is from nu1, that is
T1 to
from T1G ground term. T term is a ground term to quadrant T2G. Second one is from T1G to quadrant A2G.
A2G.
Third one is from quadrant T1GF
T1G.
to
A to T1G P.
T1GP. So these are the 3 transitions. Again, see, energy is order is E3 to
E2.
E1, or nu3, nu2, nu1. What's about wavelength?
Reverse.
It's lambda1, lambda2, and lambda3. But see, in this, see whether it may be COH2O6 or any water complex is concerned, you can have a source free absorption band. There is no overlapping, but see, same complex is there over here. So vanadium complex is there with water molecule complex is there, H2O complex. So H2O complex in lower system shows overlapping, but in the higher system, it does not have a overlapping. Okay. So this is the case for which system? You can say it is D2 system, and D7 system there is no overlapping. What happens with a D3 system? How its diagram is drawn? In the case of D3, there are
T2 के जैसा
yes C2, but multiplicity is different रहेगी ना. 3 इलेक्ट्रॉन
Yes.
है. 3 अनपेड इलेक्ट्रॉन है तो मल्टीप्लिसिटी जो है वो क्वाड्रेट आएगी. और अगेन इसी यहाँ पे एक टर्म है
40.
एंड अनदर वन इज क्वाड्रेट P. दोनों टर्म पॉसिबल है. सो इनका डायग्राम वो ऐसे आएगा. सी यहाँ पे ग्राउंड टर्म चेंज हो जाएगी. कौन सी आएगी? A term is a ground term in D3 and D8. Okay. What is next term?
Yes, sir.
Quadrat T2G and then quadrat T1G, and here is a quadrat. How many transitions are there? Here there is no overlapping. H2O6 plus 3 Cr oxalator twice minus 3. See again how many transitions are there? There are 3 transitions. Which are these 3 transitions?
A2 to T2.
Yes, so these are the expected yellow transitions. Here itself. So this is the first one, second one, and this is third one. So you can have a 3 allowed transitions are possible. First one is from with a ground term A to G, quadrat A to G2, quadrat T to G, quadrat T1G F, and quadrat T1GP. These are the 3 allowed transitions. Now see D3 and D8 system that we prove later on. D3 and D8 system, 10 dq equal to nu 1. What is 10 dq value? It is equal
10
to
लो
nu 1. Okay, so कई बार आपको nu 1 ट्रांजिशंस वैल्यू दे देगा. इसके हिसाब से आप 10 dq फाइंड आउट कर सकोगे. इसी तरह से D2 एंड D7 सिस्टम 10 dq इज इक्वल टू nu 2 माइनस nu 1. कितनी आएगी वैल्यू? nu 2 माइनस nu 1. ओके, इट्स nu 2 माइनस nu 1. तो आपके पास ये ट्रांजिशन ये सब वैल्यू है nu 1, nu 2, nu 3. सो यू कैन कैलकुलेट 10 dq using this formula. Here you can have this formula for 10 dq. What's about D8? D8 electronic configuration. It's a similar diagram. You can have a same diagram for D8. Only multiplicity here it is quadrat that gets changed. That is called there are 2 unpaired electrons. So multiplicity is 2s plus 1 value is 3. Rest of the whole things remain same. This is your diagram. Here which it is F term, that is called triplet F, and here it is triplet P term. F term is split into triplet K2G, triplet T2G, triplet T1G, and P term is into triplet T1GP. So how many transitions are possible?
3. 3.
3. So see, this is the first one, second, and this is the third one. So allowed transitions are triplet A2G2, triplet T2G, this is first. Then you can say triplet T1GF, triplet T1GP. So there are 3 allowed transitions with again energy is nu3, nu2, nu1, wavelength lambda 1, nickel plus 2 is the example. You can have a nickel any 6 ligand containing neutral ligand containing complex. So it is an example of the system. So this is a Orgel diagram for, you can say, D8 system. So if you give one 10 DQ value, so you can calculate new one, or from new one you can calculate 10 DQ value. So here what you can do, see, sometimes all these 3 transitions value is given to you, so you can use only new one for D8 system in order to calculate a particular, in order to calculate 10 DQ. So you can see all these 3 transitions value are given, but you have to use only one, that is new one. Or in case of a system, that is, you can say your system is, for example, D2 system, and if you are given all these 3 value, then you have to use only which value to calculate 10 DQ. चलो उस केस में 10 DQ कैलकुलेट करना है तो कौन सी वैल्यू यूज करोगे?
सर पिछले में तो न्यू वन था।
पिछले में 2 में D3 D8 में न्यू वन है, इसी तरह D2 एंड D8, that is न्यू 2 माइनस न्यू 1. ओके, कौन सी टर्म है? न्यू 2
सर
माइनस
याद
न्यू,
नहीं रह रहा है सर कितना था जो
देखो
गैप है।
नहीं, यहाँ पे लिखा है, देखो मैंने ये दो फॉर्मूला सिंपल दिया, D2 D7 सिस्टम के लिए एक है, और एक जो टर्म है वो ये वाले, देखो D2 एंड D7 के लिए कौन सी फॉर्मूला याद रखना है? न्यू 2 माइनस
टू माइनस
न्यू 1. ओके, एंड D3 एंड D8 के लिए
ये सब फिर
ओनली
रिवर्स हो जाएगा,
V1.
न्यू वन होगा, न्यू वन
ओनली
इक्वल टू
यस, न्यू 1 इक्वल टू 10 DQ. ओके, ये दो आपको इससे याद रखना है, तो इससे डायरेक्ट कई बार 3 ट्रांजिशंस वैल्यू प्रोवाइड कर देंगे, तो वो 3 ट्रांजिशंस वैल्यू है, उस हिसाब से आपको यूज 2 का ही करना है उसमें. ओके, कोई भी दो, फॉर एग्जांपल सी इन केस ऑफ D2 सिस्टम for a VH2O 6+3, which shows how many transitions? Here in D2 vanadium complex shows how many band? It shows only, this shows only 2 band.
3.
Okay, it is shows only 2 band, that is, and its particular value for this complex is, see, vanadium H2O 6 shows 2 band with, I will give you its value. Shows 2 band with value nu 1 equal to 1700 and nu 2 equal to 2100 centimeter inverse. Then what is its 10 DQ value? And what is 10 DQ? कैसे कैलकुलेट करेंगे?
So nu2 minus nu1.
mu2 minus mu1.
It's nu2 minus nu1. तो कितने आएगी?
Four 400.
It's a 400. Okay, simply इन दोनों में से आप इसको सब्सट्रैक्ट कर दो. So it is a 400. And overlapping is taking place in the case of H2 or D2 system is concerned. So you can have a, because of the overlapping, one transitions which is not observed. T1G है वो between इन दोनों के केस में आ जाएगी. But in case of suppose D3 and D8 system, what happens?
सीधा nu1 होगा.
इसमें दो ट्रांजिशन है ना, उसमें ओवरलैपिंग होगा तो ये मिलेगा आपको. एक तो जो है T1G F to T1G T3GF, ये वाला है ना जो ट्रिपलेट T1GF, उसमें से ट्रिपलेट T1GP एक रहेगा, दूसरा जो है वो ट्रिपलेट T1GF2 ट्रिपलेट T2G भी रहेगा. बट किसका ओवरलैपिंग हो जाएगा? जो ट्रिपलेट A2G है ना, वो पीछे की साइड चला जाएगा. ओके,
T1G.
तो दो ट्रांजिशन एक्सपेक्ट हो गए. निकल के केस में क्या होगा? चलो D3 में, D3 सिस्टम में तो तीन ट्रांजिशन सेपरेट है, तो उस केस में आपको nu1 वैल्यू जो प्रोवाइड करते हैं तो उस हिसाब से आप कैलकुलेट कर सकोगे, है ना. इफ यू गिवन nu1 वैल्यू, सो यू कैन कैलकुलेट particular 10 dq value from the nu1 value. Okay, is it possible? From 10 dq, can you calculate? See, can we calculate 10 dq from nu1?
Yes, sir.
Okay, in D3 and D8 system you can do it. Now, see 10 dq basically it is nothing but a energy difference. That is when crystal field splitting is take place in a particular complex. So exact what happens, how you are getting 10 dq value from these transitions. You can have a, in the case of triplet F term, suppose this is a triplet F term and this is your triplet P term. These are the two terms. So basically energy difference between these two terms is 15B. B is a repulsive factor. ये दोनों के बीच जो है इसका जो डिफरेंस है वो 15B वैल्यू है. अभी इनका जो स्प्लिटिंग है वो ऐसे होगा, यहाँ पे आएगी ट्रिपलेट T1G, उसके बाद यहाँ पे ये बेरी सेंटर रहेगा. यहाँ पे आएगी कौन सी टर्म? ट्रिपलेट T2G. A2 कहाँ पे आएगी? इसके ऊपर यहाँ पे. और इनकी जो टर्म है उसमें इसमें से एक टर्म आएगी ये ट्रिपलेट T1G. So what happens here? This is the way which you can have a splitting. So in a weak field crystal field splitting, what is this value from Berry center? It is a 6 dq. This value is minus 6 dq. This value is, you can have a 2 dq from the Berry center, and this value become from Berry center it is 12 dq. So what is this value?
10.
10 dq. This is the 10 dq. So this is the case of free ion, and you can have a case of complexes, weak crystal field splitting complexes. So this value is a 15B between F term and this one. This is a 15B value. This total is distance.
Yeah,
It is, see, this is a minus 6 dq with from बेरी सेंटर है, या प्लस dq from बेरी सेंटर है, तो ये दोनों के बीच में कितना डिस्टेंस होगा?
8.
यस, आपका जो न्यू वन है ना, इट इज ए न्यू वन इज 8 dq प्लस, so see new one जो है, it is a 8 dq value. Okay, but here what happens in a crystal field energy splitting, you can have a, if you go from T1GF to T1GP, so you can have a state of repulsion, or you can say repulsion factor is introduced. So that repulsion is take place more or less with the magnitude of, you can say, x energy value. So repulsive factor को भी साथ में काउंट करना है. तो यहाँ जैसे तीन ट्रांजिशंस जो थे वो V1 है, वो T1G ट्रिपलेट टू T1G, सॉरी T2G, ओके ट्रिपलेट, ये आपका V1 न्यू वन है. सो न्यू वन वैल्यू कितनी है? न्यू वन इज इक्वल टू टोटल 6 + 2 दैट इज 8 dq. ओके, इट्स 8 dq प्लस यू इंट्रोड्यूस रिपल्जन एनर्जी दैट इज x. व्हाट्स अबाउट न्यू 2? न्यू 2 is a transitions from triplet
18
T1G to triplet A to G.
18
कितना आएगा? Yes.
18 dq.
So nu 2 is equal to 18 dq plus x. What's about nu 3? Nu 3 is a transitions from triplet T1G to
6 dq plus 15b. 6 dq.
F2 triplet T1GP. Okay. So nu 3 become, you
6
can have
dq
a,
plus 15b.
yes. So it's a 6 dq, good. So it is equal to nu 3 is equal to 15b plus 6 dq plus 2x लगे, दो
Plus.
ट्रांजिशंस है ना, तो उनका. So now you tell me what is, see if you, this is equation number 1, this is 2, this is 3. What is 2 minus 1? Nu
सर
2
x क्या
minus,
था?
it is a repulsive energy, repulsive magnitude of repulsive energy. So see nu 2 minus nu 1 क्या होगा?
10 dq.
8 dq minus 8 10 18 dq minus 8 dq, x कैंसिल हो जाएगा, तो कितना आएगा?
10 dq.
इसलिए सी D2 सिस्टम के लिए हमने ये लिखा है, D2 and D7 के लिए. Is it okay? D2 and
Yes, sir.
D7, nu 2 minus nu 1 is equal to, you can say, 10 dq. So D2 और D7 सिस्टम यहाँ पे है. तो जो आपके एक्सपेक्टेड ट्रांजिशंस थे इसमें, ये आपको ऐसे लिखना है, ऐसे न्यू फर्स्ट न्यू 1 जो है, सेकंड न्यू 2 है, पहले आपको सारे जो है ट्रांजिशंस इनके लिख देने हैं. ये जो एफ टर्म है उनके T1G2 T2G फर्स्ट, T1G2 T3G सेकंड, and then T1GP it is third one. उसके बाद see you can write down the particular value. So this is a triplet. Here you can have a, आप एक काम कीजिए, इनको पहले लिख दो एक्सपेक्टेड में, जैसे ऊपर लिखा है डायग्राम में, इसी तरह ट्रिपलेट A2G and then triplet T1GP. सो इस केस में से आप डायरेक्टली ऐसे न्यू 2 माइनस न्यू 1 करके 10 d की वैल्यू फाइंड आउट कर सकते हो. नाउ हाउ टू गेटिंग 15b? सो 15b के लिए से इसको सिंप्लीफाइड करेंगे. चलो 15b कैलकुलेट करना है, तो क्या करेंगे उसमें? आपके पास ही 1 एंड 2 है
2
जो
3
इसी 1 एंड 2 को आपने सब्सट्रैक्ट कर दिया तो आपको 10 dq मिल गया. ओके, नाउ पुटिंग द वैल्यू ऑफ 2x फ्रॉम इक्वेशन नंबर, यू कैन से दिस वन.
3 minus 2 minus 1.
आप एक काम की दोनों का समेशन करो तो कैसे मिलेगा? बाय एडिंग 1 एंड 2. इफ यू ऐड इक्वेशन 1 एंड 2 तो क्या होगा? दिस इज 1 एंड दिस इज इक्वेशन नंबर 2. सॉरी, हियर दिस 1 एंड 2 को आप ऐड करो, सब्सट्रैक्ट तो कर दिया, ये दोनों को ऐड करो. सो बाय एडिंग 1 एंड 2, nu1 is equal to 8 dq plus x, nu2 is equal to 18 dq plus x. This is 1 and this is 2. Now you can add these two, nu2 plus nu1. What happens? 18 plus 8, that is
26.
x plus x, it is 2x. Okay, this is called your equation number, you can say 4. देखो दोनों में 2x टर्म है तो आप क्या करोगे? इक्वेशन 3 माइनस x रिमूव करना है. इक्वेशन 3 माइनस कौन सा इक्वेशन करेंगे?
Half 16 करो.
इक्वेशन नंबर 4. इक्वेशन 3 माइनस इक्वेशन 4 करोगे तो ये nu3 है 3 में, माइनस nu2 माइनस nu1 इज इक्वल टू, देखो nu3 है इक्वेशन नंबर 3 में, तो nu3 माइनस nu2 माइनस nu1 इज इक्वल टू 15b प्लस 6dq. सो 15b एज इट इज रहेगा प्लस 6dq माइनस 26dq minus 2x plus 2x cancel out. So how many dq it is? 15b 6 dq plus minus 26 dq. So minus 20 dq. So nu3 is equal to this one. Now what is dq? What is 10 dq?
mu2 minus mu1.
Yes, so here it is 2 into 10 dq ऐसे लिख दो आप इनको. So it's nu2 minus nu1. So your answer become 15b is equal to 15b minus 2 nu2 plus minus minus plus 2 nu1. तो इसको 15b को सब्जेक्ट ऑफ फॉर्मूला बनाओ. सो 15b इज इक्वल टू व्हाट? nu3, nu2 इस साइड आएगा तो प्लस हो जाएगा, एक nu2 है प्लस 2 nu2. सो nu2 माइनस 1 nu2 है, 2 nu2 उस साइड चला जाएगा, माइनस 2 हो जाएगा, तो माइनस 3 nu1. ओके, इज इट ओके?
Yes, sir.
हाउ टू गेटिंग b? b is equal to nu3 plus nu2 minus 3 nu1. So you are getting repulsive factor b using this formula. ये फॉर्मूला कॉमन है, से आप इसको भी यूज कर सकते हो. So this is very useful whenever you are given different diagrams, different transitions. So you can calculate particular b value, or you can calculate particular 10 dq value from these transitions. Now b value you are getting from this one. Okay, another very important term is you can say beta, that is called nephrogetic ratio.
Inverse of B.
So it is nothing but
The
you
inverse
can
of B.
say
Inverse of
beta, it is represented by beta. So it is by it is by b to b value, b complex, repulsive factor of complex for free ions, free metal ions. ये लेना आपको, तो आपको नेफ्रोजेटिक रेशियो मिलेगा. ओके, बीटा, it is you can say nephrogetic ratio. How you are getting? It is you are getting by taking repulsive factor for, or you could say Raka parameter for free metal ions. B is a Raka parameter. It's a B. It's a Raka parameter. So B complex, it is for Raka parameter for complex. And what is B? Free ions. That is called Raka parameter for free metal ion. रिपल्जन किस में ज्यादा होगा? फ्री मेटल आयन में ज्यादा होगा या कॉम्प्लेक्स में? फ्री में ज्यादा होगा. So this ratio you see probably most of time it is comes less than 1. Is it okay? This ratio is comes.
होगा ज्यादा, कॉम्प्लेक्स में ज्यादा होना चाहिए.
कॉम्प्लेक्स में कहाँ इलेक्ट्रॉन्स तो बाइंड हो जाएंगे ना. फ्री इलेक्ट्रॉन्स हो गए तो रिपल्जन जो है वो ज्यादा रहेगी ना.
हो रहा है कॉम्प्लेक्स में डीजेनेरेसी हो रहा है.
और कॉम्प्लेक्स में डिजेनरेसी हो रही है तो ऑर्बिटल का स्प्लिटिंग हो रहा है ना, एक दूसरे से दूर जा रहे हैं. वहां तो नॉन डिजेनरेट स्टेट है. See, we see the one example to calculate how this equation or this is useful. So you can have a, suppose we go for a weak field complex with two absorption bands you are given. Sometimes 15B value may be provided, B value may be provided. You can calculate nephrogetic ratio. For D2 system, like V3, it has been observed that triplet P state lies (1 to 9 to 5 centimeter inverse above to the triplet F state. So calculate nephrogetic ratio you are given Raka parameter B for free metal ion is equal to 862 centimeter inverse. So first you can calculate B for complex. What is given to you? Anybody tell me from this?
एनर्जी गैप GP से GP दिया है.
Yes, you are given
15.
triplet, yes, triplet F2, triplet P. This energy gap is nothing but a 15B value for complex. It is given, this is given 12, 9 to 5 centimeter inverse. You can have a CB free. So what you can do? You can go for calculating first B from this one. So B for metal ion. Okay, so this is you are getting 6 to 6 centimeter inverse. Then next you go for calculating B beta Raka parameter, that is called 6 to 6 divided by 4 free metal. It's a 862 centimeter inverse. So centimeter inverse gets cancel out. So what is your answer? Become 0.726.
0.72.
Yes. So this is the way you can calculate nephrologic ratio. It is very, very important. You can also calculate, see, you are given nu2 and nu1 value. So you can calculate B also from that. 15B equal to nu2. You are given, suppose, all these three value, all these three transitions value. So you can use formula 15B is equal to nu3 plus nu2 minus 3 nu1. From that you are getting B. B for free metal ion is provided, and you can calculate beta nephrologic ratio. Okay, so these are the different ways to calculate nephrologic ratio. उस केस में से आपको तीनों जो ट्रांजिशन है उनकी जो डिफरेंट एब्जॉर्प्शन बैंड है, all these three is provided. Now similarly another system is you can have a D3 and D8, especially nickel system, that is called D3 and D8. What happens in this case? In the case of D3 and D8, here it is triplet F and here it is triplet B. So again this energy gap is 15B. But this is split into triplet A to G. Then here it is triplet T to G. This is berry center. You can have a triplet T1G. And here it is triplet T1G. Now see again this here repulsive energy, that is X amount, it is increases from normal level. It is again by X value. Here this factor is we are including, this is X. Okay, in all this case you can have also here it is by X factor. So in this case what happens if you go for calculating, this distance is 10 dq, of course it is 10 dq minus 10 dq, this is minus 2 dq and this is plus 6 dq. So you tell me first one, what is nu1? Nu1 is equal to how many dq? Nu1 is your transitions from triplet A to G to
T2.
triplet T to G. So it is
10
nu1 is a 10 dq, only 10 dq. Okay, here there is no X. In this case X is the what is X is a magnitude of X energy, is it is a value owing to the non-crossing rule, or you can say with the same symmetrical state. So nu1 is 10 dq. What is nu2?
12 dq.
Nu2 is
18.
18. It's 18 dq. तो इसमें क्रॉसिंग हो रहा है बेरी सेंटर से ओके ऊपर जा रहे हैं आप. सो क्रॉसिंग में क्या होगा, एक्स इंक्लूड होगा ना. कितना आएगा एक्स? एक एक्स है, बट वो ऊपर आप जा रहे हो तो ऊपर जो 6 dq है नीचे 18 है, तो यहाँ पे हम उस केस में प्लस किए थे, यहाँ पे एक्स माइनस करेंगे, एक्स
Negative.
नेगेटिव हो गई. यस. व्हाट्स अबाउट यू कैन हैव ए nu3. nu3 is of course 15b
15p plus 12 dq plus x.
plus 12 dq plus x. yes.
सर ये माइनस एक्स क्यों हुआ?
से
नीचे नाम है
माइनस
ना,
यहाँ
एनर्जी
पे
नीचे नाम
देखो
है,
जो नॉर्मल जो
डाउन हो रहा
T1G है ना, उससे एक्स अमाउंट एनर्जी कम हो रही है. यहाँ पे ट्रिपलेट T1G आ जाएगा, इसलिए रिपल्सिव फैक्टर यहाँ इंक्रीज हो रही है. यहाँ पे एज इट इज है,
मींस न्यूट्रल, मींस न्यूट्रल.
इससे न्यूट्रल. remaining two, see these two are neutral, look at here, दोनों केस में ये एक्सटेंड करके क्लियर कर देता है. दिस इज ए ट्रिपलेट T to G एंड दिस इज ए ट्रिपलेट A to G. नाउ आगे के जो डायग्राम है उसमें भी ये चीज जो है आप मेंशन कर देते हैं ताकि यू कैन, यहाँ पे डायरेक्ट हमने वैल्यू लिख दिया था कैलकुलेशन में, बट यहाँ जो ट्रिपलेट T1G है उससे एनर्जी यहाँ कम होगी अमाउंट बाई x. ओके, जैसे इसमें इंक्रीज हो रही है यहाँ कम हो रही है, बट उसके बाद नेक्स्ट जो आएगा आपका ट्रिपलेट ये वाला जो उसकी एज इट इज रहेगी, और ये A2G है तो उनके भी एज इट इज रहेगी, और इनकी जो एनर्जी है वो यहाँ इंक्रीज होगी ऐसे बाय अमाउंट x. तो इसके सी इस केस में आपको क्या करना है, सी इफ यू गो फॉर T1G तो यहाँ से यहाँ तक ये काउंट होगा. T1G जो है आपका, ये फर्स्ट वन इज न्यू वन. यहाँ अमाउंट सी एनर्जी इंक्रीजेस बाय अमाउंट ऑफ x. ओके, जो क्रॉसिंग हो रहा है उसमें यहाँ पे एनर्जी इज इंक्रीजेस बाय अमाउंट ऑफ, और ये आपकी ट्रिपलेट T1G यहाँ आ जाएगी. तो यहाँ से आपका ट्रांजिशन स्टार्ट होगा x प्लस दिस डिस्टेंस दैट इज कॉल्ड हाउ मेनी dq, 8 dq. So x plus 8 dq is a new one. Look at here. उसके बाद क्या होगा,
यस सर समझ गया.
सिमिलर वे यहाँ सी इट इज, ये नॉर्मल रहती है, इसकी एनर्जी चेंज नहीं हो रही, इसलिए यहाँ पे न्यू वन इक्वल टू डायरेक्टली हमने 10 dq लिख दिया है. न्यू टू के केस में क्या होगा, न्यू टू तो ये पूरा जो डिस्टेंस है 10, 2 एंड 6 कुल मिला के 18 dq हो गए.
18 minus
तो
x.
उसमें से x माइनस कर देंगे यहाँ से. यस, एंड हियर इट इज, ये जो T1GP है तो उसमें यहाँ तक ही काउंट करेंगे हम. सो यहाँ दिस इज ए T1GP, तो ये x
Plus
तक
x.
काउंट करेंगे. तो इस केस में न्यू 3 इज इक्वल टू 15 डी की तो है ही, 15 डी सॉरी
18
15 बी, 15 डी है प्लस ये जो पूरा है वो 18 डी क्यू हो जाएगा, 12 डी क्यू.
plus x.
ये इतना जो है वो 12 डी क्यू. उसके बाद जो x फैक्टर है तो यहाँ से ये x ये तो इंक्लूड हो गया इसमें 15 बी में, तो ये एक x ऐड करेंगे हम, दिस इज कॉल्ड प्लस x. सो दीज आर दी 3 वेरी इंपॉर्टेंट इक्वेशन. तो यहाँ से आप डायरेक्टली सी प्रेडिक्ट कर सकते हो कि न्यू वन इज इक्वल टू 10 dq, है ना. 10 dq जब कैलकुलेट करना है सो यू कैन गो फॉर न्यू वन. नाउ हाउ टू गेटिंग b, तो उस केस में क्या करेंगे, दोनों x वाले इक्वेशन से उनका समेशन कर दो सेकंड एंड थर्ड का. सो न्यू 3 प्लस न्यू 2 इज इक्वल टू 15b प्लस 18 dq प्लस 12 dq, 30 dq. So what is 15b value? 13 dq is equal to again it is 3 into 10 dq. What is 10 dq?
T mu1.
New one. So see new 3 plus new 2 minus 3 new 1, this is equal to 15b. ये फॉर्मूला सी दोनों में सेम आएगी. देखो, whether the system is D3 or you can have a system is D2 and D7, this is remain same. Is it okay?
Yes sir.
This formula does not change. This is remains similar in both the case. So very important things is you can calculate repulsion factor if you having transitions value. For example, if you having this diagram is still left to draw, but say nickel H2O6 plus 2, that is D8 system, shows 3 band नेट में भी ऐसे क्वेश्चंस पूछे गए हैं जिसमें 10 DQ कैलकुलेट करना है। R8 मैक्सिमम 8500। सबसे कम एनर्जी होगी ना सी, इनको आपको न्यू 1 बोलना है। उससे ज्यादा एनर्जी है वो न्यू 2, इससे भी ज्यादा एनर्जी उनको क्या बोलेंगे? न्यू 3। इज इट ओके? ओके। सबसे ज्यादा एनर्जी उनको न्यू 1 बोलना है, उससे कम है उनको न्यू 3। सो कैलकुलेट 10 DQ B4 complex and Raka parameter. Sorry, B4 Raka parameter for complex and nephrogetic ratio. So nephrogetic ratio for, so for that you require 10 DQ value for free ions. Nephrogetic ratio beta, Raka parameter for free metal ion is equal to given to you, that is provided. Here suppose for free metal ion it is given 20, you can given 48 system. Just a minute. That is, this value is 708. So it is 1030 centimeter inverse. Okay. So now how to getting all this calculation? कैसे calculate करेंगे? चलो. What is given first? What is न्यू 1?
25, 8500.
8500 centimeter inverse. न्यू 2 is
14500.
न्यू 3 is 25300 centimeter inverse. So 15. What is 10 DQ first?
mu1.
Because this is D8 system. So न्यू 1 is at 10 DQ. Okay. So 10 DQ, or you can say octahedral splitting is equal to, this is your first calculation. What's about next? That is for B4 complex. So 15B is equal to न्यू 3 plus न्यू 2 minus 3 न्यू 1. What is न्यू 3? In this way, see, you are getting this one. B value you can calculate in this way, that is 25300 plus 14500, that become 39,800 minus, what is 300 minus, it's a 3 into 88,500. So it's 25,500. So your answer become 14,14,300 centimeter inverse. So what is B value?
Divide by 15.
Divide by 15. So it become 1,4,300 divided by 15. So 953. So you can calculate nephrogenic ratio beta. For free metal ion, it is given. Call करो रोहित अभी. Call करो. हाँ. Call करो छो. I want to 10 વાગે હું ત્યાં ઊભો રહેજો હો. ફોન કરું. લેક્ચર ચાલુ છે ને અમને ફોન જ કરો. So it become see B for complex and B for metal ion. What is for complex and what is for metal ion? Complex it is 953.33 upon metal ion is already given 1030. So your answer become
0.9255.
yes, good. 0.925. So this is called B, or you can see sometimes calculate percentage beta also, percentage nephrogenic ratio, that is 92.5. You can just multiply it with 100. Okay, so you may got percentage beta value also. Is it clear?
Yes, sir.
Yes, sir.
Okay, so see this type of simple questions, simple calculations you may ask in the exams. Now see in the next lectures, we will going to see a particular diagram, Orgel diagram for one more system that is called D6. Thank you very much.
Sir,